If you ask a supercomputer to roll a die, do you get a truly random number, or just a digit that feels random? The researchers behind this paper investigated whether large language models can actually handle statistical distributions. We increasingly trust these models to build synthetic datasets and randomized tests. However, the authors identify a critical gap. We do not know if these systems can faithfully simulate randomness without external tools. To find the answer, the researchers conducted a massive audit across 15 distinct probability distributions. They tested 11 frontier models, including GPT-4o and Llama-3, using a sample size of 1,000 to rigorously check for convergence. The experimental design relied on two distinct protocols. First, they asked models to generate a list of numbers in a single batch, allowing the system to see its own history. Second, they made 1,000 independent requests, where the model had no memory of previous draws. The difference between these two methods revealed a fundamental weakness. When generating numbers independently, 10 out of 11 models failed every single distribution test, and increasing the sample size actually made the performance worse. These statistical failures cause significant problems in real-world applications. For example, when asked to randomize multiple-choice answers, models showed a heavy bias towards specific letters, and demographic generators failed to produce promised diversity. The study concludes that large language models do not possess a functional internal sampler. They have learned the linguistic patterns of what randomness looks like, but they cannot execute the underlying mathematical functions faithfully. Ultimately, this work serves as a warning: do not rely on language models to play dice with your data. For more details on this statistical audit, visit emergentmind.com.